we're going to prove the product rule. Product rule says if h of x is a product, now let's stay away from h, p for product. If p of x is equal to f of x times g of x, then the derivative of p is f prime of x, g of x, plus f of x, g prime of x. Basically, you have f of x, g of x written down 2 times. Take the derivative of one of them, say g, and then here take the derivative of the other, which is exactly the same as this. I just switched the 2 terms. Or, if you prefer, you can take the derivative of the first one in the first term, and then the derivative of the second. And this is the same game no matter how many functions you have. Suppose you have 3 of them, f, g, and h. So, this time, you write it down 3 times. You write it down 3 times. And then, in each one of these, you take the derivative of 1. Here I'll take the derivative of f, and here g, and here's h. It's easier to do it in order, of course. I mean, since addition commutes, you know, in my opinion, you should go in order f, g, h. You want to take the derivative of f here, and g here, and h here, fine. But notice how I went in order? That way, by accident, you don't use the derivative of g twice. Okay, so let's go and prove this. Let us go and prove this proof. And yeah, let me state it now. It's best to remember it this way. Most textbooks, which is mind-boggling to me, and I'll show you why in a moment, they'll have you remember this. And this is not a good way of remembering it. Because, well, you'll see when I do the quotient rule. Okay, proof. So, p prime of x is equal to the limit as h goes to 0 of p of x plus h minus p of x over h. But this is equal to the limit as h goes to 0. Well, p of anything is f of anything times the g of the anything. It's f of the anything times g of the anything minus p of x. And here you get a freebie. They told us what p of x is. In fact, they always do. Now this gets divided by h. Now we have the benefit of seeing the answer. Somehow we want to get f prime of x. And we know what f prime of x is. It needs to be this. Now we clearly have the h in the bottom. And I shouldn't have prime. And we also have this piece. It's right there. So what I'm going to do is, since it's being multiplied by g of x plus h, I'm just going to write f of x plus h times g of x plus h, and then I am going to take something away. I am going to take away f of x times g of x plus h. Notice how I can factor out a g of x plus h, and then I'll have what I want. I'll have this. Okay. But of course, okay, first of all, let me write this a little bit smaller. So I have the limit as h goes to 0. I'm going to write down this piece. And then out of nowhere, I admit, I'm going to take away f of x times g of x plus h. So then I have to add it back. I just have to add it back. F of x times g of x plus h. So that's 0. And then let's not forget to take away f of x times g of x. And all of this mess gets divided by h. And this is equal to the limit as h goes to 0. So I'm going to do this piece first, and then plus that. In the first piece, I can factor out g of x plus h. Got g of x plus h times f of x plus h minus f of x. Plus, in here, I can factor out an f of x. And what's left over is g of x plus h minus g of x. And this whole thing gets divided by h. Okay. Now, this is equal to the limit as h goes to 0 of g of x plus h times f of x plus h minus f of x. And I can divide, so it's this piece that gets divided by x, and this piece that gets divided by x. Now remember, if you have a product over c, you can write this as a c times b or a times b over c. I want to put the c here. And I'm going to do the same with the next one. Plus f of x times g of x plus h minus g of x. And naturally, I want that piece to be divided by h. Okay. So we're getting close, but I do realize that we needed a lemma. So it's that limit of all that. But a limit over sum, I can write as the sum of the limits. The limit of h goes to 0 of g of x plus h times f of x plus h minus f of x over h plus the limit as h goes to 0 of h of x times g of x plus h minus g of x over h. Now, okay, so now for each of these two limits, there's a product. So I can take the limit of the first factor, times the limit of the second factor, plus do the same thing here. The limit as h goes to 0 of f of x times the limit as h goes to 0 of this. Now, the first limit we have to look at carefully. So let's come way down here. What is the limit as h goes to 0 of g of x plus h? Now, we're going to assume g is, give me a second, is differentiable. Now, g of x plus h is equal to g of x plus h minus g of x plus g of x. Okay, after all, this cancels. So this becomes the limit as h goes to 0. So why I'm doing this is to build up the derivative. It equals to the limit of g of x plus h minus g of x plus g of x. Okay, now remember, h is not 0. So h over h is not 0. So what I'm going to do is I'm going to take this piece, and multiply it by 1 as h over h. Plus, let's not forget that. Okay. So this is equal to the limit as h goes to 0 of g of x plus h minus g of x over h times the limit of this. The limit as h goes to 0 of h plus the limit of this. The limit as h goes to 0 of g of x. Okay. Well, this limit is just g prime of x times this limit. Well, if h goes to 0, then h goes to 0. Plus, now this limit. Now this limit has nothing to do with h's. So the limit as h goes to 0 of g of x is just g of x. Well, this times 0 is 0, plus g of x is g of x. I want to be very clear here. This had to be well defined. This had to be well defined. You can't say, oh, this is 0, therefore this times this is 0. That's not true. Infinity times 0 is not 0. Okay, this had to be well defined. This had to be well defined. So then, since this is well defined, and I multiply it by 0, I really do get 0. So in the end, what we just showed is that as long as g is differentiable, that limit is 0. Okay, so we come back up here and we say, oh, we just did this limit. It is 0. No. It is, so let's see what it is. I apologize. This limit, which we did all over here, we concluded is g of x. But basically, h is 0. But that's only if it's differentiable. So that limit is g of x. That is, this limit here is g of x times, well, that limit is just f prime of x plus this limit, just like earlier, f of x has nothing to do with h, so it's like a constant times this limit, which is g prime of x. And I really suggest that you remember it in this order. And the reason is that the quotient rule, with two minor exceptions, is in this order. It's f prime of x, g of x, minus f of x, g prime of x, all over g of x squared. So, other than the denominator, the difference between the product and the quotient rule is the sign in the middle. Okay, now, if you, couple of comments. Since this is subtraction, the quotient rule, at least the numerator, is not this minus that. They don't commute. Actually, most books don't even have it this way. They have g prime of x maybe f of x first, plus f prime of x, g of x. This doesn't match the bottom at all. It doesn't match this at all. Well, you can say, oh, it's switched. Well, you know what? Addition switches. You can switch an addition. Let's keep the product rule this way. This way, this and the numerator of the quotient rule are very similar. Difference is, instead of plus, you have minus. Remember the product rule this way. And it's easy to remember it based on what I said. You have a product of two things with a plus in the middle. Write it down 2 times. First, second. First factor in the first term, the first function gets primed. In the second term, the second function gets primed. And that's exactly what the quotient rule says. Except, again, instead of plus, it has minus. But we're getting ahead of ourselves because we didn't prove the quotient rule. But just to have it in front of us, f of x, g of x, plus f of x, g of x, prime, prime. Remember the product rule this way. Don't go by what your book says, unless it says this. Okay, that completes this one. And then next we're going to prove the